I'm going to teach you the OCR A-level computer science floating point subtraction using both the regular method of subtraction and 2's complement. So first, right, let's look at the question. So in this example, both numbers are in the 6-bit mantissa and a 4-bit exponent, and they're both normalized. We need to perform the operation in the above format. So it has to be in a 6-bit mantissa and a 4-bit exponent, the result. Okay then, so first, the first number, which is this, let's express it in its true binary form without the exponent. So exponent is equal to 0, 1, 0, 0, units, 2's, 4's, 8's. So there's 1, 4, so the exponent is equal to 4. And the mantissa, that's equal to 0 point, the decimal point always goes here, 0.10010. How many times do you have to shift the decimal point to the right? Well, 4 times. That's what the exponent tells us. 1, 2, 3, 4. So the number in its true form, it's 0.1001.0. That's the number. And that's a double check. Make sure to emphasize that it's a double check. I'm going to turn this into its true form. That's equal to units, 2's, 4's, 8. 8 plus 1. 8 plus 1, which is equal to 9. Now number 2. So this is 1, 2, number 2. That's 0, 1, 0. The exponent is 0, 0, 1, 0. Units, 2's, 4's, 8's. We see that there's only 1, 2, so the exponent is equal to 2. Mantissa, the mantissa is given as 0.10010. How many times do you shift the decimal point? 2 times. 1, 2. So the number is equal to 010.010, which, as a double check, I'm going to put in this column. Units, 2's, 4's, and this is a half, a fourth. You won't be able to see that, but that's a fourth. So that's the same as 2 plus a fourth, which is equal to 2.25. So we have to subtract both of them. So 9 minus 2.25, that's equal to 6.75. Right, you can do that in your head easily. So now let's perform the binary subtraction. 0.1001.0 minus 10.01. Let's pad the zero. Let's pad it with some zeros. Right? How many? 0 minus 0, 0. 0 minus 1. For that, we'll go here, because that's 0. We have to take away 1, and that turns that into a 2. That becomes 0, and that becomes 2. Don't ask why, just understand it. So we take 1 from here, that becomes 1, and that becomes 2. 2 minus 1, that's 1. 1 minus 0, it's 1. So now, 0 minus 0, 0. Repeat the same process. So 0 minus 1, well, we have to take away a 2 here and put there. And for that, we need to take away 2 here. So that becomes 0, and that becomes 2. Then we need to subtract 1 from here, and that becomes 2. So 2 minus 1, that's 1. 1 minus 0, it's 1. And that's the number. And to double check it, that's the same as, so that's units, 2's, units, 2's, 4's, and that's a half and a fourth. So that's the same as 4 plus 2 plus 1 over 2 plus a fourth, which is equal to 6.75. They're the same, so we got this method correct. However, we have to normalize that and express in the above format, right? So for it to be normalized, it should start with 0, 1 if it's positive, or 1, 0 if it's negative in 2's complement. However, this is clearly a positive number, so we can remove that 0, that extra 0 here, and we can remove that 0 there. So we want to express it with 6 bits for the mantissa and 3 bits for the exponent. So we have to move the decimal point here. 1, 2, 3. We shift it 3 times to the left. So therefore, the new number is 0.11011, which we can see that's 6 digits. And then shift of 3. 3 in binary, that's the same as 0, 1, 1. Add an extra 0, so it's 4 bits. So we have 0, 0, 1, 1. And that's the result. And looking at the mark scheme, we know that's the correct result. Now, this with regular subtraction, regular binary subtraction. However, there's an easier method. So now, pause the video and attempt to do this question using not regular, 2's complement subtraction. Okay, so here's the answer. First, get the first number, the exponent of the first number. Just write XP, EXP, or whatever, the way you like it. 0, 1, 1, units, 2's, 4's. That's the same as 3. So, the mantissa, that's equal to 0.10010. We need to shift this decimal point 3 times. 1, 2, 3. So the new number is 0100.1. Correct? Yeah, it is. And then the second number, the exponent, that's 010, units, 2's, 4's. So that's equal to 2. And the mantissa is equal to 01110. Don't forget the decimal point. How many times do we shift it? Twice. 1, 2. So a number is equal to 011.10. So now we have to subtract them. 0100.1 divide minus 011.1. Now, we could do the regular method of subtraction. However, we could also do the 2's complement method of subtraction. Generally, if they don't specify, you have to do the regular method of subtraction, which would give you the following result. So 1 minus 1, that's equal to 0. 0 minus 1, well, we don't know, right? That's not possible, so we have to carry over a 2, right? So we carry over a 2. For this, we have to carry over another 2. So that becomes 0, that becomes 2. And because we had to carry over a 2, subtract, and it becomes 1. So 2 minus 1, that's 1. 1 minus 1, that's 0. 0 minus 0 is 0. And yeah, the rest is just easy. However, we can also do this in a different method, using 2's complement. In regular maths, 5 minus 4 is the same as 5 plus minus 4, right? Basically, we just added a negative number, a negative version of this number, right? So we can do the same with binary numbers. Instead, we can convert it into a plus, get this, and convert it in its 2's complement form, which, if we do it, gets, so we hold this one, so it keeps there, and then we convert the rest, we shift the rest, so we have, and the 0 should go there, so it would be 0, 0, 1, 1. don't forget we need to have the same number of digits for both of them so that the 2's complement subtraction can go through. So 1 plus 1, that's 2. Carry over the 1 there. 1 plus 0, that's 1. 0 plus 0, that's 0. 1, 2, and then carry over the 1 here. So, actually my bad. What we could do is 1 plus 1, that's 2. Then carry over the 1 here. And that basically symbol is the same as carrying over the 2. But it becomes 1 along the way. So that's 0. Then 1 plus 0 plus 0 is 1. 0 plus 0 is 0. 1 plus 1 is 0, carry over the 1. 1 plus 1 is 0. And carry over the 1. And that becomes an overflow bit, which we ignore. Overflow, which is ignored. Right, because we only have this format. So the answer given is 0001.0. See how in both ways they're the same? Then we convert that in the above format, 5-bit exponent, 3-bit mantissa, normalized. Right, so normalized, that means we can knock off these 2 zeros at the end. And how many times do we have to shift it? 1. There's 1 shift. So it'd be the same as 0.1. And then, so it can be 5 bits. You add the extra zeros. So 0, 1, 0, 0, 0. 3 zeros, 5. And then it's a shift of 1. So the exponent is equal to 1. 0, 0, 1. That's the answer. And that should be pretty much it. And yeah, that's pretty much it. Alright, any questions, put in the comments.